Okay, let's assume that that's working. It's definitely working on some platforms. Not sure if in YouTube, but it should. I'll quickly check if the live is on. Sorry for the improvisation. At some point, we might edit this and remove the first part so that people can skip through this directly. Okay, yeah, the title has changed. Great. Let me go share the link. Let's share it in Telegram. All right. Okay, I think that we should be able to start now. Let me share the screen. Can you correctly see the screen? You should be able to see the Genservers part 1 thing that we did last time. So I will start with a very quick review on what we did last time. The main idea behind that is that as we don't have a recording of the first one, we just can have a very quick review. Actually, this is in a vertical position. I will try to make that horizontal. Yeah, let's do that. This will take just a minute. And now you should be seeing that. I need to ping my screen. To ping my screen. Let me see if I can do that. This is what you meant? Okay, let's just do this. So this is what we saw last time, right? We first had an introduction on concurrency and parallelism. We saw that concurrency was independent execution. Parallelism was being able to execute those in parallel, actually. Then we had a first introduction to processes in Elixir. We saw how to run them using lambdas. Then we saw how to send messages between processes so that we could get the output out of them. We learned how to use the receive functionality, how to use the spawn functionality. And then we started our first server. Basically, we built just a function that calculated a sum or a multiplication. And we basically created a process. We sent a message with a request. And then we added a way to send a response with send to the caller so that we could get the answer. And then we basically did this whole interaction where we had the shell send a message to the process, receive the answer with the receive function, and then put the result in the output. But then we saw that we had a problem with that. The main one being that the calculator was a one-time thing. Like once the function that was executed in the process died, then we didn't have a process anymore. So basically, we didn't have a calculator anymore, which was not very nice. So what we did was we basically did a loop function so that the process that we started received a message, a request, and then instead of dying, it just looped again so that it could receive a new message and answer it. And that's the basic building blocks for a server, right? What else did we do last time? Eventually, what we started doing is we started abstracting a bit. Like we saw that from the outside world, we didn't care that much about needing to manually call and receive functions, like doing calculator server call and like doing this manual marshalization or marshalling of the parameters and the function call. Like this is like very manual RPC style stuff. So we try to abstract that and have like a public API in our calculator server. So then the interaction seems a lot more server-like, right? We just call spawn, we call sum, we call multiply, and we get the answers just as if we were calling a regular function, which is kind of the same idea behind like original RPCs, right? So that's what we saw last time, but we're still missing a lot of stuff. one of the things that we're missing is state. This function does not have any state. This server is pretty much useless. Like you would never use a server for just calculating stuff, right? You would just use a function, because what's the use in having a message be sent and then sent back and have all of this overhead for something that can be just like a regular module, right? Also, is that font size all right, or do we prefer a little bit more zoom on this?
Bigger would be better because this screen is a little bit.
I should have started with that. Thank you. Is that big enough? Nice. Okay, at least this happened with the first one and not with the current one. So yeah, let's actually build a new notebook so that we can new notebook, and this will be Genservers part 2. The first one is state. That's the first section. So as I said last time, this is being done live. So live coding, as everyone knows, has a lot of problems. We'll try to make everything as smooth as possible, but we may have issues, and let us know if something doesn't work on your side, or we will ask you for patience if something goes wrong in our side. But thank you so much, and we'll just start. So, and of course, like this is not like a seminar or whatever. So like if oh, the screen didn't change. Thank you so much for letting me know. Share this tab instead. This is a problem of using multiple tabs. Yeah, that brings me to the next issue, which is like always feel free to just interrupt me. This is not like a seminar or a class or anything. Like feel free to just interrupt me, ask some questions. If there are some people in YouTube watching, you can also ask in the chat, although I may not immediately see it. But if there are some comments, then anyone can just tell me and I will address them. Okay, so second part, which is state. As I was saying, we will never, ever, ever want to build a server that doesn't have any kind of state. Because the main reason why we have servers is that we want to have something sequentialized. And the typical reason why we want to have something sequentialized, like executing in some kind of order, is because we will probably have multiple processes trying to access the same state. And instead of putting a mutex or something like that, we will probably just want a server over it so that the server can receive requests and execute state changes on its own state and then send responses back. So the first question will be, how do we add state to a Genserver, right? So what we saw last time, let me just copy and paste what we had before. Give me a second, there's an alarm going off. Okay, fix that. So let me just copy and paste what we had before. You will not see a change of screen for a couple of seconds, but I will open the part 1 and I will copy what we had, just so that we can have the template. Okay, go back. So this was what we had in the previous workshop, right? We had a calculator server, which was the version 2, and we had a public API, a loop, and a call, right? The call will probably remain exactly the same, because this is very simple functionality. It's just having a server, sending an operation, sending the caller so that we can get some responses, and then just receiving. I will actually simplify this to a simple line so that we can fit more in a single screen. And then we have the, let's call it, if you are if you work in JavaScript, this is kind of like an event loop, right? We just well, there's a lot of difference with an event loop, but basically this is a loop. We receive messages, we process them. In this case here, we handle them basically, and then this is the actual handling, and then we send the response back. So what example could we use for state? For instance, we can have a stack server, right? Are you all familiar with the stack? Like you just pop things into it, you push things into it, you pop things into it, and it basically represents last in, first out logic for a container, right? So what will be our public API? It will be push, and we'll push an element. We'll see what. Oh, sorry. The spawn will probably be the same. So push and we'll have the server, an element, and we'll just call for a function push with an element. Then eventually we'll also want to pop the last element, which will not receive any parameters, right? Because popping the element just gives you the last one. And we'll just call the server with a pop and no other arguments. And that's it. We don't even need a tuple for that, right? It's because we are sending a message. Like we're not we don't need to send tuples. We just did because we wanted to send a single thing representing both the operation that we wanted and the parameters. Okay, and then the loop. The thing that will change here is that instead of receiving sum and multiply things, we will receive other things, like we will receive push an element and pop and no other thing. These are the kind of things that the kind of messages that our server will be handling. So the only remaining issue is that before this was very simple. We just used the parameters to calculate the response, and then we sent it back. But now, aside from didn't change the sum, thank you. That was very quick. So the first main thing that you will see is that it's for that now the parameters that were sent to me over the message will not be enough. We will also need to save the state somewhere. So how will we ever do that? Okay, the idea is that as we mentioned last time, tail recursion allows us to not build new stack frames in each function call, right? So here, each time that I call loop, I'm not creating a new stack frame in memory for this function call. I'm basically reusing the frame because we don't need the results of this for anything. So I can basically just, I don't do this manually, of course, the beam does it, but it deletes any local variables that might be here, and it just reuses the same memory space for this call. And this loop that just for now didn't have any parameters can have a parameter like state. Like this, right? So the idea is that we can do both things. We can send a message to the caller, but we also can modify this variable, or instead of modifying, creating a new state in a functional way. And basically, the next time that I will call loop, I will call it with a new state. So for the next iteration of this function, we'll start with a new state. And that's the way we handle state in Genservers. I will now finish this example and we will be clearer. But you need to think Genservers as state machines. They have a state, they receive a function, and they know how to use that event to transition to a new state. And then they are in a new state, and then they are ready to receive functions from that state. So that's basically how it works. So now that I have my current state, which is my stack, I will just call it stack for simplicity, right? So I can, if I received a push, what do I want to do? If I received a push, what I want to do is basically add an element to the stack. Is that right? So what we will do is basically, let's give us a bit more space here. Push doesn't return anything, right? I just return OK, because the only thing that I need to do is have some idea that this worked. That's it. That's it. Like, it doesn't return anything. But what I will do is I actually need to change the state, for instance, like this. And the new state will be the element that I'm pushing concatenated with the previous stack, right? So basically, what I'm doing here, let's add everything a little so it's more understandable, is we will receive a message, and if it's this kind of message, I will send an OK to the caller, but I will also return this from the receive function, which is a new stack with one more element. And in pop, what will I do? It will be slightly different. The first thing that I will do will be to pop the element. I will send the popped element because that's what pop does. And then I will just have the new state as the rest of the list, right? Is everyone familiar with this syntax? it basically means that this is the first element and this is the rest of the list. This is a pattern matching over lists. Yeah, and of course, again, let me know if there's anything related to the code that's not like immediately understandable. And this is my new stack or new stack, we call it. And then we call loop with new stack. This basically means that for the next iteration, we'll have the stack modified, which means that we either have one more element or one less element, depending on what function what function call we received. The call we will not modify at all. And the only thing that's missing is that previously we were calling spawn without any arguments, and also kernel spawn was spawning the loop function, which didn't have any arguments. And now we need to give it a first value, right? So what we will do is adding that right here. Instead of just calling loop, we will call loop with an initial empty stack, which is just an empty list, right? So basically, let's see if this, well, we also want to change this stack, right? Let's execute this to see if it works. Okay, it seems like we have a new module, and let's start testing it. So first we spawn it, right? And let's, did this work? It worked. Then we can pass functions to it, like push. So we'll push hello, because we can push anything into this. Then we can push number, this, and then we can pop elements and inspect them to see if this is working correctly. Just inspect. And same here, because we push 2 elements and then we pop 2 elements. What will happen? So basically, these are the inspects. So if you see this, basically the first element that's popped is the last one that was pushed, which is 42, and the second one that is popped is the first one that was pushed, which is hello. So everything is working correctly, right? So basically, if you see this is like fundamentally different from what we were doing last time, because the stack now has state, and you can see that because like we don't need to pass any parameters here. The state is present in the process, right? And how is it present in the process, right? Like processes don't have like attributes or variables. This is not like Java coding where you have like private attributes which are the state of the functions. And basically the way that we represent this state was with arguments. With this looping function contains an argument, and this argument contains the whole state of the server. And we used recursion to represent that. Okay, any questions until now? To see any questions, so I will just continue. And also, again, feel free to just interrupt me. Okay, so there's one thing that we haven't even got into, right? Because here, if you see the stack, this has a lot of repeated functionality from the calculator that we did before, right? The spawning is very similar. We just call kernel spawn and have a Lambda here. Then the calling functionality is very similar too. The looping function is very similar too. Like here, there are some specific things some lines of code that are specific to the stack, like precisely these ones and these arguments. But the whole receive, modify state, send response back loop is a completely generic thing, right? We could have that abstracted in a generic server module, and the next server that we build, we wouldn't need to rewrite this stuff every time. And like I basically copy pasted, but ideally I wouldn't need to copy paste everything that I took from the calculator server, paste it here and modified parts that changed. That's very error prone. So ideally I should be able to have a module that was generic enough that would help me bootstrap Genservers from scratch. So that's the whole idea behind Genservers, which is basically a short name for generic servers. Because right now we're building like specifically tailored servers. So I will What I will do is I will get all of these copy pasted again. But the reason why I will do it is so that we can refactor this code. And we can start dividing the things that are specific for the stack and the things that are generic for any kind of server. So let's go line by line and see what is related to the stack and what's not related to the stack. So first we will separate this between public, like stack API, and server API. And what here is related to a server? Like here, not so much. But what is related to us, like, sorry, it's kind of the other way around. The call is something that's related to servers, right? Like knowing how to call something is related to servers. Spawning, same. But here, for instance, we have, and looping is also related to servers. But knowing what's the initial state, in this case, an empty list, is something very specific to stacks. Because if I was building, for instance, a state transition server or something like that, this would be like an initial state or something like that. So we will take this out so that we can have this as pure server functionality. And we just have an init function. And this way, now this is like a pure stack API, right? And we can have this as pure server API. Because like any server can have this. Any server can will have a spawn function. It would call the loop function, and it will just call the init function that is specific for that for that specific server. And push and pop are more like stack specific stuff. These are more like a bit more obvious. And the init as well is stack functionality, right? Okay, what else? Then this is the hardest part. We will try to make the loop. We will try to separate the parts that are generic for the server. So we will just separate this between server functionality and stack functionality. And if you recall, we mentioned that like the looping function in itself, we'll just call this state now, so we make it more generic. Then new state here, new state. Like the looping functionality, the receiving functionality, the sending functionality even is more related to the server basic functioning. What is related to stacks are what arguments we have, what responses we have, and how we calculate new state, right? Those are the three things that we need to take into account. So ideally, we will just turn this into a single receive, where we have just a generic request, and we delegate the handling of that request to the stack specific functionality. So what we do is we will have a handle call function for which we will give the current state and the request, and this will return both things that we need: the response that we need to give to the user and the new state, right? And let me just move this out of here for now. We'll see how we organize it. And what would we always need to do? We'll need to send the response back to the user, or not actually the user, but the caller. And we need to return the new state. We don't even need to do a variable here. We can just, well, we can do that, yeah. New state is this, and then we can just loop with the new state. And if we want like a more Elixir-like version, we can just pipe this into a loop function, which is nice. So this is completely generic now, right? This loop functionality doesn't know anything about stacks, which is nice. So basically, I receive a message which contains the caller and a request. I delegate that request to whatever handle call function we will have, which will be stack specific. I will give the state and the request, and then that will be that will calculate a response and my new state. I will send the response, and I will return the new state so that we can continue looping with a new state, and that's it. And now I only need to implement the handle calls, like the call handlers that are specific to the stack. And basically, this will perform the stack specific behavior from this thing that we had before. So what we will have is, if we're sending the state, which is the stack, and the request, which is push an element, basically for this one, it's a simple one. We just need to return the response, which is OK, and we need to return the new state, which we already had calculated before, which is very simple. We can even fit this in one line if we are like one line maxes. Okay. And then we just need to handle call. We just need to handle the other kind of call, which is what happens if we receive a pop. Not even a tuple, just a pop. Well, here we will probably need a couple more lines, but we will do this exact same thing we did before. We will pop an element and have the rest in a separate variable, and we will return the response first, which is the popped element, and the new state, which is the rest. And I think that that's it. It's a very similar, a very simple thing. Let me just do this. And if we are one line maxes, we can say, okay, this is the stack, right? We can pattern match that before. We can just say that this is popped rest, and I'm sending pop, and let's just do a one line thing where I just return this. And why are we doing all of this work? Like this was a lot of work. The main reason for this is that if you paid enough attention, we can just separate this and have a single section of code with the server functionality. This is pure server functionality. If you see here, there's no stack references here. And then this is all stack functionality that at some point may use server functionality, like here, like calling stuff, but it will only use it. It will not need to manually write anything. So if we can separate now this between two modules, writing a stack server will be as simple as this. I will just write a simple API. I will write handlers instead of writing like sending messages around. And the handlers will only say, hey, this is your previous state. This is the message you have. What we will do about it? We just have an OK response and this, and that's it. And this also, this calling functionality is not even from the stack, right? It's a server thing. It's just knowing how to call stuff. So look at how small the stack functionality is now, which is amazing. So now we will try to do this, like take this even further. I will not create a new one for this. And let's try to separate this between a generic server module and a stack module. I will see if there are any questions. I don't think we have any. Perfect. So let's just put generic server here, which is our own gen server, basically. Then we will end the module here, and this will be our stack module, which we'll call v2, right? Because we already have a stack module here, and it will clash if we don't change the name. And now, of course, this is not like this is a server function, so I need to call it by name. And what else do we have here? Oh, yeah. And we can have the spawn functionality. We can have our own spawn for the stack that just calls the generic server one. And we'll, yeah. So here you will see that we will have a problem. Like if we want to just tell the generic server, hey, I want you to like spawn a stack. And then when you are in the loop functionality, I want to call handle call. But the gen server doesn't know where the handle call function is. And it would be like very lame to put like stack here, because then again, it's not generic, right? I can only use this for a stack. So what we will do here, there's a better way to do this, but it will take too much time. So maybe for a different workshop, or at the end if we have too much time. So what we will do is that when we spawn something in the gen server, we will pass it an implementation module. What is this? And then our state will be two things. Basically, we will start a loop with a state, but also I will give it the implementation so that we can actually call implementation.handle call, and that's it. Oh, I quit. I hope this was saved. Yes, because we can have functions as parameters. We can also have modules as parameters. So basically, I will just say here, hey, generic server spawn stack v2. So basically, what this is saying is, hey, what I want to, like, this is your module, and this will be part of your state. The module you're implementing is part of your state. And the reason why I can use this, why this is useful, is because then when I want to handle call, I will just call, hey, handle the call using this specific module. And the server still doesn't know what module that is. Like when I say the server, I mean like the server module, right? It's saved in the state. What else do you need to change? I think that's it. And then I think that it may already be ready. That's one and too many.
And in 24, we need a dude there.
There's a do missing somewhere. Thank you. Well, in what function did you say it?
At 24, line 24.
24. Nice. That's a good eye. You guys are paying attention. I'm glad to hear that. Function call isn't used. This is probably because it was private originally, but now it's an interface, and it's something that should be used from the outside world. I will move it to the API section here. And the loop is a private thing. We will never call loop manually. And also now loop has two variables, right? Implementation and state. So what we will do is just return to our old thing like this, and we will manually call loop with implementation and state, right? Implementation will always be the same. It will not be changed, but I still need this to have it as a parameter in loop, because I'm getting some comments. New state. Did I misspell new state somewhere? Oh, new state here. Thank you. Thank you so much. Okay, I executed it, and there's still some errors, but I will fix them immediately. But what I was explaining here is that now my state is comprised by two things, the implementation and the actual state. And the implementation will not be changed at any point in the looping functionality. It's basically a constant, but I still need to keep it as a parameter, because if not, I will lose it. And the next time I want to call loop, I still want to know what implementation we have, so that we can call the correct handle call. The same here. We want to be able to initialize our state, and for that we will use the implementation module. And I think that's it. Those are the only two places where I need to know the implementation: handling the calls and initializing state. Because if you think, like, generic servers are like, the server part is about communication. It's about having a process, spawning a process, sending messages, returning messages, having a loop, etc. Implementation are about state and state transitions. So what's my initial state? And if I get a call, what's my new state? That's all it does. That's all what an implementation is about. Okay, what else? What do we have next? It says that this is a typo. Is there anything else? Okay, it might be enough. Let's just test it now to see if it works. So just check how small my stack server is now. Like, if I don't need to change the generic server anymore, because imagine that this is a good implementation, this is a pretty bad one, but we can improve it then later, then implementing a new server is extremely simple. It's just this, which is kind of why Genservers are a thing in Elixir, right? It abstracts a lot of functionality for you, and it's out of the box. It's right out of the box. You download the language and you have it already available for you. So let's just test it. Stack v2 spawn and assign this to this variable. Let's now push some elements, the same we did before. Stack v2. Let's actually just copy paste, because we're lazy. You need to do hard work on hard things, but not on simple things. and we'll just replace this here with P2 and see if this still behaves the same. And it does. So it's amazing. Basically, we built exactly the same thing as before, but we have the effort. I mean, if you already have the generic server, we only had to do these like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines compared to this big 27-line thing that also had a lot of server functionality. So that's the whole idea behind Genservers and why they are useful. They abstract a lot of functionality that you don't want to re-implement each time. So, any questions for now? If not, we can move to the next section, which is casts. This is a first small improvement that we can do, because basically we see here, like, there's something that I mentioned last time, which is that when you have a generic server or a gen server, when you send a message to it, you get blocked waiting for the response, which usually is the desired thing, right? Because you want to send a message and wait for the response. But sometimes you are not waiting for any kind of response. For instance, when you push an element, all I want to know is that the gen server received the message correctly, but I don't want to wait until the gen server calculates the new state, maybe is also like handling other calls and wait for it. That's usually not desired. So what I usually want to have is, aside from calls, I want to have something called casts, which only sends a message and does not await for a response. If you look here, we are only sending OK, which is kind of lame. Like we shouldn't need this. So let's just implement our cast. We'll copy paste everything again, because that's how we roll over here. The only reason why I'm copying a generic server is because I'm changing the functionality. But when we already have it fully coded, then you don't even need to do that. Okay, and a stack v3 probably, because we will use the new gen server. And what's the new thing that we will do? We will define a new API called cast, which receives, of course, the server and an operation. But in this case, we will not do this whole sending a thing. Oh, actually, this will be pretty much the same. We will send the server an operation, but we will not wait to receive anything else. But the key difference here is, okay, in the loop function call, we are handling every request the same way. We handle the call, we send a response, and then we have a new state. So I need a way to differentiate between calls and casts, because I want to do different things for them. So what I will do is, without the implementation knowing any of this, I will just add one more thing to what we send over here. So we will send the caller, we will send the operation, and I will also send a small atom stating if I'm doing a cast or if I'm doing a call. So what I will do is basically I will state here that we were sending a call and here that we were sending a cast, right? This is all hidden from the stack, like this marshalling of arguments. And afterwards, what I will do is I will say, hey, this is a request that you're getting. Is this a call request? Then we do this, right? No, not here. That was a bad place to put it, here. If we receive a call, then we do all this. But now I can also receive a cast with a caller and a request. The format is the same. Oh, the caller is not even relevant anymore, right? Because I will not be returning anything to it. So I'll just delete it. Goodbye caller. We just have the cast atom and the operation. And then what difference will I have is that I will have a new state, but I will not compute a response because I don't care about the response. Implementation, handle cast, state request. And that's it. This should return a new state. I don't even need to assign it to a variable because I'm assigning it outside of the receive. I will just tabulate all of this so it's clearer. And that seems like it. And now I can just create a handle cast, which is basically the same as the handle call. The only difference is that instead of returning a tuple with a response and a new state, it will only need to return the new state, because we don't care about responses, right? Handle cast. All of this remains the same because the stack logic is the same. The only different thing is that, oh, it wasn't for this one. It wasn't for the pop. It was for the push. That was my bad. The push was the one that needs to be a cast. So we will not care about this OK, basically. So what we are doing is something that makes sense. We're not even adding things. We're deleting things from the stack. And the only other thing that I will do is now push will be a cast. And that's it. So from the stack point of view, not much happened. From the server point of view, we added a cast API. We added a cast pattern match that doesn't give a new response, that doesn't do the sending of the response. The cast API also doesn't wait for a response. And then we just called the handle cast handler. And now the stack can both handle casts and handle calls. Okay, let's compile this. Okay, Genserver cast is undefined. I forgot to make this the Genserver v2, which is the one that supports casts. What else is new? Okay, that seems like enough. So we will copy and paste our test again, change all of the versions, and see if this is working. Let's just update to v3. Oh, yeah. I broke everything. Okay. Exception. Stack v2 handle cast is undefined or private. So why is that happening? Because I forgot to say, hey, this is very interesting actually. So I forgot to say, hey, server, you're spawning a stack v3. So I'm actually spawning a stack v2 module because I forgot to change the version here. So basically what's happening is that instead of spawning this module, it's spawning the previous module, which didn't support the handle cast. So it basically failed. So let's do this. Let's re-execute this. Let's do it again. Did I not execute this? Okay. I need to actually manually go to the button. It says stop. What does it say? Stop. I think I may have broke something. Yeah, this is yeah. So let's stop this. Let's actually reload the page because the previous time that I did this, we had some problems. So let's execute everything again. Well, I actually don't need to execute previous stuff, but let's just execute this. Okay, it seems that it works, and then okay, that's fixed. So everything is still working, and I have now casts and calls. I can do calls that send a response back, and casts that don't send anything back. And I already have a generic server and a stack. Any questions for this part? Let me check that. We have a private chat, and we're getting some questions from there. Some typo corrections, and then it says, do we need to send self? Aren't we using it for replying? Maybe we already did. That was already addressed. It was resolved. Thank you. Yeah, that was probably for casts then. And effectively, we don't need the self for casts because we don't need to send a response. That's a perfectly good question. And then I had another comment which says we can use module to avoid this kind of mistakes. That's a great one. Here I had a problem where I was saying, hey, I confused what module I was passing. And if I'm referring to this same module, then I can just do this. This is a kind of macro that refers to the module that you're writing, which is a great way to not make these kind of confusions. And this is very used in Genservers and stuff like that. So that's a perfectly good one. This error wouldn't have happened if I had used this one. Thank you for the comments. Okay, let's go to the next section. We have 10 more minutes. So maybe, just maybe, we can talk a little bit more about handling info and daemons. Not demons like in the mythical creatures, but demons in the cron jobs kind of technical thing. So daemons and handling info. So I will do this a bit shorter than I would like because we only have 10 minutes, but I will send you the full notes afterwards so that you can check like the full rationale behind it. So the idea is that these Genservers that we built for now only can handle two types of calls, right? Calls and casts, and that's it. But it would be nice if they could receive calls, casts, and whatever else. And the whatever else had like a default way of handling things, right? For two reasons. One reason is that it would be interesting for error handling, like being able to, hey, if I send a message from this, it wouldn't be stuck in the queue, I can just discard it or whatever. But also, there's a very interesting thing that I can do, which is that if I have a gen server that sends a message to itself, which is something that we didn't do right now, right? Like for now, our servers only receive the messages from the outside world. But I can have a server send a message to itself in the future, like saying, hey, like send a message, but only after 5 seconds. And then when the server receives it, it basically can loop with itself and perform a repetitive task, like, for instance, push notifications, like checking every 5 minutes if there's a new message or something like that. So the thing that we will do is trying to implement a new server. I will copy and paste everything again, like this. And our goal, like I will start with the API first this time so that we understand what we want to do, and then we can see if we can implement it correctly. But basically, yeah, let me just, okay. I'm seeing if we can fit this in 7 minutes. I think we can. Let's try enough, and if we can't, then we just like we just stop. So basically, spawning will be the same. We probably won't be doing anything about this. We don't want to build a stack now. We want to write an email sender, which is an interesting new case, right? So what does an email sender do? For instance, if at some point you dealt with this, you know that if you send like massive emails, that's spam, and your server will probably be banned from Gmail and everything like that. But there's very legitimate use cases for this. Like, for instance, if you have a web page with like 100,000 users and you need to send a notification for all of them, like, for instance, hey, you need to immediately update for this because there was a security bug, we fixed it, but we need you to update. Or, for instance, hey, there's an airdrop coming tomorrow. You probably all of you want to apply to this or whatever. And there's legitimate use cases for sending emails to everyone, but you don't want to get banned by Gmail or by Microsoft or whatever. So what you do is, instead of sending 100,000 emails at once, you basically you throttle yourself. You basically send like 10 messages, then 10 more messages, then 10 more messages, and something like that, and that's it, right? So how would we do this? Well, ideally, we would have a server that's an email sender, so that any kind of event that triggers an email just sends, hey, server, I want to send this email, but I will continue doing my stuff, so I will just give this to you, you handle this. And the server, every like 10 seconds or so, will send a small batch of emails. So for instance, we want to have emails sent every second instead of immediately. So let's send interval. We will put this in milliseconds. And we will send 3 emails each time, right? These are module attributes. These are like constants that are specific for this module, if you didn't use this before. And this is not a stack anymore. This is the email API. And what things will we have? As for this will be exactly the same. The only different thing is that we will be using the version 3 of the Gen server and this module, which is nice. We didn't have to modify that. Then we won't have push and pop. The idea is that I want to queue an email, or queue a series of emails. Queue emails. This will be an email list. And the only thing that I want to do here is just a cast, right? Generate server v3 server. This will be the message called queue. This is the request, and this is the emails. And that's it. And we won't have any other public functionality. That's it. And as for initializing, for now, I will only want to have an empty list. The idea is that my state will be just a list. What does that mean? That my state will be a list of emails that I need to send. And I will get new emails. I will just save them there, and periodically I'll check if there are new emails and just send them. So, but now I want to do something else aside from just initializing state. This is my state, that's fine. This is the goal of init is to return the first state, but we also will do something called scheduled work. This is a function that we need to write, huh? We don't have it yet. But basically, scheduled work is what I told you a couple of minutes ago, right? What I will do is that immediately I want to tell myself, hey, in a second for now, check emails. That's what I want to do. That's what schedule work should do. So this is a private function. We will delete this eventually, and this is email functionality, like a private functionality. And schedule work is basically this. Process send after. I will send it to myself. Check emails and I will wait the interval. Send interval this. I will just change it to check. What does this do? Let's break this down. Basically, this means hey, I want to send a message. I want to send this message to myself, which is the email sender server is sending a message to itself. I want to, the message that I am sending is just this plain atom, is just check emails. And I will send this message after this amount of time. This doesn't mean that the server is sleeping. What this means is it basically sends this to the inbox, to the mailbox, to the email sender mailbox, but it will make it available after this interval of time. So this means that nothing is blocked while doing this, but after a second, this message will appear magically, thanks to the PIM, in the server mailbox, right? And the great thing about this is that I can now write this check emails thing, like something that I'm receiving, but this will not be a cast, right? Sorry, let's do one thing at a time. I'm getting ahead of myself. First, what we will do is handle this cast, which is queue emails. This is a simple one. It's very similar to what we did before. Handle cast. We will, what will we receive? We will receive the queue, which is our current state, the email queue. We will receive the queue request with some emails to add to the queue. And then we will just do queue plus emails. So basically, I'm queuing this in a first in, first out way. There's a more efficient ways to do this. There's a queue module in Erlang. We won't be using this for simplicity. But basically, I'm just queuing emails. That's it. That's very simple. So where am I actually sending the emails? Well, I need to handle info. So this is what I said before, right? We receive the state, and we receive any kind of message. We won't be receiving here a cast or a call. We will be receiving this message that I sent to myself, which is like a fully generic one. And what I will do here is we will receive check emails, which is like the full message that I'm getting. And then what I will do here is, well, the actual email sending, right? So I will send up, first I will get a batch, like the first 3 emails. From this queue, I get the first 3 emails, right? And if you never used enum.split, basically it tells, hey, this is the first part, this is the 3 first elements, and this is the rest. Sorry about that. And what I will do is, basically I will send the batch. We can now implement whatever we want to do with emails to send. This is not like that. And then, as you might recall, when we manually implemented the loop functionality, we had to manually call the loop function from within this function again. And we will do something very similar here. Inside of the handle info, we will not call handle info directly, but we will schedule work again. So each time that I start working and do some stuff, then I will schedule some more work. And then I will return the new state, which is the remaining emails. Right? And then I will just add some like sending functionality. Email, like if there are no emails to send, I will just do okay. So that can happen sometimes, which is nice. It means that we are up to date with them. And if I have this, then I will just expect sending a batch. And for each email, in emails, I will just inspect the email. This is a very lousy email sender, of course, but this is like here would be my actual email sending logic. And that's pretty much it. But we need to support the handle info, right? Because if we added this thing that's not a cast, not a call, what is it? So basically, I will go to my generic server, and I need to add a new handle info like process, right? Something that supports this kind of message, like generic messages. So I will just go here, and I can just receive any other message. And if I receive something that's not a cast, it's not a call, I will just call implementation handle info. I will give it the state and whatever other thing got here. So that's nice. That's not much more work. I think that's it. I don't know if I need to do anything else here. I think that not. So let's test if this works, and we can just end the workshop because we're already a couple of minutes in. Generic server v2 is already defined. I basically forgot to change the version here. Oh, version 3. Are we using 3 here? Yes, I'm using this module. Generic server v3 cast. Okay, let's check if this works. Well, maybe it works. It's then, what should we execute? We will spawn an email sender. And then we will add some emails to send, right? So we don't have time to do very nice emails. Hello, this is the first email. Second email is the second email. I don't know, what else can we write here? Let's just write random stuff. Spam email, car warranty. I don't know, got an airdrop, whatever. These are our emails, and the idea is that we want to queue all of these emails, right? But we want the server to only send 3 at a time and wait a second between each other. That's the whole thing with it. Let's see if it works. Okay, sending a batch, sending a batch. Okay, that's nice, right? It sent a batch. The first batch was a hello email, second email, this random stuff. The second batch of emails was spam email, car warranty, you got an airdrop. And the nice thing is that this is already working. Like any process can queue new emails. Like sender, like it seems like it's not working because it's basically not getting any new messages. It's not checking like what it's doing is checking every second if there are new emails, and as there are no new emails, it's not doing anything. But we can just send a new batch. Let's just do numbers now, and it still works. It's still sending the messages. And if there's not a full batch, that's no worry. It still works. So this is a very powerful thing, the handle info, because we can build basically Genservers that periodically do stuff without needing to tell it anything, and they work asynchronously. Like I can have, for instance, a Phoenix backend with a very used page, and user connections that are doing stuff can just send these email sender messages to tell the server, hey, I want this email to be sent, but I don't want to get blocked myself because I still need to send stuff back to the user. So you handle the work separately in a different process. And the email sender says, okay, I'll save this, and it will just continue periodically sending stuff. And this is very useful for when you cannot or should not do stuff immediately and synchronously. Typically, emails or using external services that might throttle you if you send them too many messages. That's the typical kind of issues. Or if you want to do any kind of generic task as a typical cron job, we actually use this in the consensus client for periodically downloading pending blocks. So basically, when when a new block arrives and we don't have any parents for it, what we do is we just put that inside of a gen server, which is called pending blocks. You can go check that now. And the thing that pending blocks does is periodically it checks if the parents of the blocks are already available, and if not, it tries to download them periodically. And it doesn't do all of this at the same time, it just does this periodically. Which is nice because basically no one needs to get blocked waiting for the parents. This just like does it in its own time. And when the parent of a block is found and then it's connected to a checkpoint, then eventually you can sell all of those blocks to the fork tree. Okay, we're 7 minutes late already, but that's all that I wanted to say today. Do we have any comments or questions for the workshop? Okay, I think not. We don't have any comments on YouTube anyway, too. So let's, if you have any kind of more questions, like I will send you, this is like the live version, but I also have like a more tidy version that I can just send it to you. I will after a couple of minutes. And you can just review that, review the video. And if you have any more questions, you can just ask them in the Telegram. But yeah, thank you all for joining and for staying until the end. See you next time.
Thank you.
Yeah. Thank you.
Thanks.